Right, this is the second part of lesson 17 for the foundation, and it was all to do with perimeters and areas. Right, okay, so let's do a square so I can get some of these shapes right. There, might use your imagination. Right, everything's centimeters. So if this is 3 centimeters, then the properties of a square are such that all 4 sides are exactly the same length, and we've got lots of right angles in there. So if we want to do the perimeter, which is all the way around, we just go 3 plus 3 plus 3 plus 3, because everything is the same. 12 centimeters, and now we use the square symbol. So the perimeter equals, and the area equals. Now what we do is we multiply 2 adjacent sides together. So this will be 3 times 3. Oh, made a mistake already. I was rushing on for the area. Right, scrap that. Let's go back to there. And 3 times 3 equals 9 centimeters squared. So the linear measurement is just centimeters, and the square one is just centimeters squared. So this will apply pretty much to a rectangle. So if this is 10 and this is 5, if we're working out the perimeter, opposite sides are exactly the same as each other. So the perimeter will equal 10 plus 5 plus 10 plus 5 equals 30 centimeters. Now, if we're going to work out the area, it's going to be 5 times 10, or 10 times 5, it makes no difference. 50 centimeters squared. Good. Now, it must be more difficult shape than this. That's too easy for us. Yeah, so we've got triangles now. Triangles. And there are lots of different kinds of triangles, and we've got a triangle like this, and this is a right, R-I-G-H-T, a right angled, and we have got an isosceles triangle. Ooh, isosceles, and we have got an equilateral, and we've got a scalene. Right, so if we want to find out the perimeter, now remember this does not include Pythagoras, because that's another lesson. Without the knowledge of Pythagoras, can we find the perimeter over here? Well, you need all 3 sides, don't you, and add them up together. That's the only way you can do that. Pythagoras will teach you something else, but that's later. If you want to find the perimeter, what is an isosceles triangle? An isosceles triangle is got 2 sides the same, and that is that's sort of labelled, denoted by 2 little dashes across there. That means the left side and the right side are the same length. Obviously the right angle, or may not, is a right angle there, 90 degrees. Now with an isosceles triangle, if you knew the bottom and one of the sides, you could work out the perimeter, because the other side, the left and the right, are the same. Equilateral, equal, with an I, yeah, all 3 sides are exactly the same. So if you knew just one of the sides, you could just multiply that by 3 and you would get the perimeter. A scalene, all 3 sides are different, so you can't really do much with scalene triangles, and they don't bother with them in GCSE because there's not much to do with them. As far as area is concerned of a triangle, right, so area of a triangle. So let's go back to our right angled triangle, and there's a little formula to remember here. The area of the triangle is equal to half times the base times the height. Okay, and this can be squished down to half base height. That's the base, and that's the height. Now, one thing to remember is the height is vertical. Yeah, it must be the straight up and down vertical, because if we have, say, let's move down a little bit. If we have a very poor equilateral triangle, it's still area equals half base height, but remember it must be the vertical height here. That's the base, vertical height. So we'll put some numbers in there and do a couple of examples, shall we? Okay, let's do a couple of examples. So here is a right angled triangle, and we'll call that 6, and we'll call that, it's a bit bigger, isn't it, 8. So the area of centimeters, the area is half times base times height. You don't need to put the multiplication signs in because it's sort of algebra type stuff, which is half, which is 0.5 if you're doing a calculator, times the base times 6. Now, because they're all multiplying, no one has precedence. You don't need BIDMAS to do this, so you can go 6 times 8 times a half, or half times 8 times 6, or 6 times a half times 8, and blah, blah, blah. Any which way you choose, it doesn't make any difference. So a half times 8 is 4, 4 times 6 equals 24 centimeters squared. So you must know the vertical height. Right. Now, one thing that can catch you out, that lots of people do this, right? Well, they don't, do they? Not many do. Once you've learned it, it's okay. So what we're going to do is we're going to have the vertical height as 16 millimeters. Yeah. And this is going to be 2 centimeters. Now, we know the area is half base height, but you must be careful with this. You cannot multiply two different types of measure. Yeah, two different things. You can't multiply 16 by 2 and end up with 32, because that won't happen. They might prompt you to say give your answer in square centimeters or something, so you've got to change one of these. I'm going to change that into millimeters. Yeah, and so 2 times 10, because if we go from centimeters to millimeters, you multiply by 10, equals 20 millimeters. So now I can do the area equals a half times the base is 20 times the height is 16, and half of 20 is 10. 10 times 16 is 160 millimeters square. Okay, if I were to change them both to centimeters, I would have to divide that number by 10. So I would have got 1.6 centimeters. So the area equals a half times 1.6 times 2. Okay, a half of 1.6 is 0.8. Right, so 0.8 times 2 is 1.6 again. Yeah, look, half times 2 is 1. So that will equal 1.6 centimeters squared. And you see there's not a difference of just multiplying by 10 when you do with area. It's 100 times bigger or 100 times more on the units. Now, we're going to deal with four-sided shapes, 4 sides, and they are called quadrilaterals. Yeah, quad meaning 4. So the first one is this one. Remember, we're only interested in perimeters and areas really, but now we're talking about areas mostly. And this is called a parallelogram. Now, there's a word in there, parallel, and it means that if you have two lines, they don't have to be the same length, that are parallel to each other. They never get further apart, they never get closer together, and they're often seen with this on there, a little arrow, supposed to be the same size, or maybe an arrow on the end like that. Yeah, either will do, and that tells you that these are parallel. Now the parallelogram has got parallel sides. The top is parallel to the bottom, and the side is, well, I'm going to have to do two so we know the difference. The side is parallel to the left, is parallel to the right. It does also happen that this is the same length as that, and this is the same length as that. We saw that in the isosceles triangle. Now, how do you work out if you had that and 4? Because they're the same length, if you wanted to work out the perimeter, it's just going to be 8 plus 4 plus 8 for the bottom plus 4 for the left. 12 and 12 is 24 centimeters. Now, what about when you want working out the area of one of these things? Right, the area of a parallelogram is the base times the height. Yeah, and again, remember, it must be the vertical height. So if this is 5 and this one's 10, it's going to be 5 times 10 equals 50 centimeters if it were centimeters squared. Now, don't get confused if they put a number on the slopey side. We don't need it. We don't want it. It's in the way. Vertical height times 10. And there is a way with our good friend Pythagoras or trigonometry even, where we can work out the vertical height if they're not given to us, but not in this lesson. Not in this lesson. So it's just base times height, same as a rectangle. Why is it the same as a rectangle? Let me go back. Because if I took that triangle there, if it was made of paper, cut that bit off, I could then slide it along and it would be over there. So if I ignore that bit, add that bit, I've got a rectangle. So that's why it's a rectangle. Same thing. Now there is another shape, a four-sided shape. There are lots of shapes, and this shape is called a trapezium. Now the trapezium does not have to have these two sides being the same as each other. They can, these two are parallel, but not the sides. You could have a trapezium like this, yeah, where it's the top and bottom are parallel, but the sides can be anything you like. Now, we're going to call this A, and we're going to call this B. Just for the purposes of this is what the formula is to find the area of a trapezium that you will find in any book. And we need the height again, don't we? The vertical height. So, because this is short and the bottom is long, we need to find the average of the two. And the way we find averages is to add the two together and divide by 2. We were doing that when we were finding medians and things like this, and it landed in between two numbers. So the area of a trapezium is A plus B, yeah, top and bottom, divide by 2 times the height. That's it. So let's put some numbers in there and do one. So we've got, say, 8 and 10 and 4. So this will be 8 plus 10 divided by 2 times 4. 8 and 10 are 18, divided by 2 is 9, and 4 nines are 36. 36, I have to think there, and we call it centimetres again. So, A plus B divided by 2. What's the next wonderful shape we've got in our arsenal? Oh, we've got some, we've got a couple of questions here that are not easy, yeah? Right, so 10 centimetres, 10 centimetres, all in centimetres. And I'm going to try and do this the best I can. From halfway, we've got that. From halfway, hang on, let's come there. We've got that. And then we're going to do another one down there. And another one down there. Now, not to scale, so don't worry about it. This is in the middle, yeah? So it means that we've got 5 there and 5 there. And what our task is to find the area of all of that, yeah? Not that bit that's gone over the line, but all the yellow bits. I could have just done stripes, it would have been much easier. All the yellow bits. Right, so how do we do this? Well, we need some more information. That's just not enough, is it? Yeah. So we need something like this is 2 and this is 2. And the whole thing is 8. Okay, so how do we begin to find this? Well, here's a triangle. Let's take this out there. And we can use half base height, which is half times the base is 5 times the height is 2. So this equals 5 centimeters squared. This is exactly the same. Yeah. So this one will also equal 5 centimeters squared. Now, this, we've got a rectangle. So there, the rectangle is going to be 2 by the same number up there, 10. It's going to be 2 by 10. So 2 times 10 equals 20. Yeah. And all we're left with is this big triangle in the middle. Yeah. Now we don't know how high it is. Now what I failed to let you know is that these two and these two are parallel to each other. So it means that if this and this line are parallel to each other, so you start from that bit there, which is 2 down, and you go all the way up to level with the top. So you've climbed up 2. So this one is going to climb up 2 as well. So we can split this. Oh, we don't even have to split this. If we know that that is 2, we can take that big triangle out there, like that, and we've got a height of 2 and the base of 10. So we can do half base height is half times 5 times 2, which is a half times 5. Oh no, it's a double triangle, isn't it? So it's not 5. The base is going to be 10. Could have done it in 2 halves, 2 little triangles. Half times 10 times 2, which equals 10. Okay, so what have we got all together for the yellow? We've got 5 and 10. 5 plus 5 make 10, plus 20 make 30, plus 10 make 40. So the yellow is 40 centimeters squared. And just for curiosity, 10 times 8 means the whole rectangle is 80, so the yellow bit is half. Now, some people may be able to see that if you took this yellow shape at the top and slid it down, you'd fill in the bottom half of the shape. So they can get complicated. They can get complicated. So let's have a look at this one. Right, now we're going to do a wall. A wall. We're going to paint a wall. Now this came from a question I saw a long time ago, where somebody was painting the side of the village hall, and they wanted to know how much paint they needed. So first of all, you need to find the area of the village hall. So there's the side of the building. They're going to do this in meters. So we've got 6 meters at the top. We've got 7 meters is the height of the bit. We've got 5 meters for that side, and we've got 3 meters. 3 meters for that side. And that's all the information they give us, apart from we need to know that, and we need to know for that. So we've got enough there to find out. Now, the trick with these kind of questions is if you can't see immediately, you know, there's trapeziums and rectangles in there, but if you can't see immediately what to do, chop everything up into triangles and squares and rectangles. Yeah, so I'm going to put a line across there, and I'm going to put a line across there. Now I've got two triangles and 1, 2, 3 rectangles to work out. So the height of this triangle, or the base, whichever you want, is from there to there is 5, all the way up is 7, so this must be 2. The height of this one is all the way up is the same as that, is 7, and this must be 3, so 7 take away 3 is 4. Nowhere near to scale, but that's always the way they do it in the exam, so you can't measure. Now that is 2, because it's the same as that, and that is 4, because it's the same as that. Now we've got enough information to do all of them. Yeah, so I'll label them up. A is going to be half base height, which equals a half times the base is 2 times I said base, and I meant to write the number 2 there, times 2 times 2, which is 4. Half of that equals 2. B, again, the triangle, half base height. This time it's a half times 4 times 4, which equals 8. C is a straightforward rectangle, which is 2 times 5 equals, I'm going to go right over there, 10. D, big one. D is 6 times 7, which is 42. And E, which is this one over here, is 4 times 3, which equals 12. So the area of the whole thing, we just add them all up. So 12, 54, 64, 74. 74 meters squared. And that went on to go and buy paint from the shop, and how much would it cost to paint the wall and things. But we don't need that. We don't need that. So what we're going to do is one more. It's a nice triangle question. If I can find it. There it is. So we've got, can I draw, I'll just draw it freehand, everybody. Yeah, so we've got a triangle like this, and we've got something like this. So these two lines are not, the sloping lines are not parallel to each other. And we've been now charged with the task of working out the area of that. I'll put some numbers in so we got a chance. 6 and 3 and 8 and 2. Now, eagle-eyed people amongst you can see that there is a big triangle and a smaller triangle that sits within it. So if we work out the area of the big triangle and then subtract the area of the small triangle, what we're left is the stripy bit. So that's what we need to do. So the area of the big triangle, of course, is half base height, which equals a half, times the base, which is these two numbers together, which is 10, times the height, which is these two numbers, which is 9. So that's 90, and a half of 90 is 45. So that's the big triangle, is 45. The area of the small triangle is again half base height, which is a half, times the base is 8, times the height is 3. So 3 eighths are 24, half of 24 is 12. So the area of the stripy bit is going to be this, take away this, which is 3 and 33, whatever it might be, centimeters squared. Excellent. So that's enough for triangles and four-sided shapes. So we did a tiny little bit on circles. Here's a circle. And all the way across a circle is called the diameter, as long as it goes through the middle. halfway across, i.e. from the middle to the outside, is called the radius. Now you'll see you can have a radius that goes to the right and a radius that goes to the left. Therefore, the diameter is twice as big as the radius, or the radius is twice as big, twice as small, or half as big as the diameter. The bit round the outside now becomes a circumference. When it's a circle, it's not called the perimeter, circumference. Now we've got a couple of formulas to remember here. We need to work out the circumference equals pi d. Pi, that's the letter pi, which is about 3.14. Yeah, but there is a pi button on your calculator, so please use it because your answer will be more accurate. And d stands for the diameter. So if this circle is I don't know, 20 centimeters diameter, we would simply go pi times 20. And I'm going to do that on my calculator right now. And I'm going to go shift pi times 20 equals 62.83. 62.83. Now they might want your answer in something called terms of pi, in which case you don't need to work out the 3.14 etc. You just take this pi times 20 and say that's 20 pi. Now this is length, yeah, so this will be centimeters or similar, centimeters or similar, or inches or yards or whatever else. Now if they give you one where they've given you the radius, say, I'll do another one, do another circle, yeah. So let's draw a circle, and you've got, there is a circle, here's the circle, radius 14 centimeters. Calculate the circumference. Right, so what are we doing here? So we know that the circumference equals pi times d. The radius is half the size of the diameter, so this is going to be pi times 28, which would be, in terms of pi, yeah, 28 pi. As a decimal, pi times 28 equals 87.96, or 87.96 to centimeters, and I've rounded that to 2 decimal places. So there's all sorts of things going on with these, yeah, so you don't need to know all of that. Now the last bit, I don't know how far we got, I don't remember. Yeah, now let's do another circle. The last bit of this is the area of a circle. Now here we go, I'm going to do there, and this is the radius. Now the new formula, the area of a circle equals pi r squared. Pi times r squared. R squared is radius squared, which is whatever number it is that number squared times itself. So if we have a radius of 10 centimeters, then this will be pi times 10 squared, which is pi times 100, which in terms of pi would just be 100 pi. Very little to work out, yeah? But as a decimal, pi times 100 will be equal to 314.159 centimeters squared. Now, because it's an area squared, and that one was to 3 decimal places. So we've got the area given the radius. Now, what happens if we've got a circle? Here's a circle, diameter 8 centimeters, yeah, What's the area? Okay, so area equals pi r squared. Area equals pi radius squared. Now the radius is half the size of that, so that will be times 4 squared, which is 16 pi centimeters squared. As a decimal, you would go shift pi times 4 squared, and all these buttons are on a calculator, and that comes out as 50.27 centimeters squared to 2 decimal places. Okay, so that is the end of that